per the little decal on the front here, every 8 hours, which is every day, check the condition of the screen here, shake out any big particles that are going to prevent the airflow going through the engine, and every 40 hours, which is every week, look through the radiator. If it's clean, fair enough. If it isn't, get some compressed air and blow through the back of the radiator, blowing the rubbish out through the front. On this side of the engine, you've got the expansion tank for the radiator. Like we said earlier, it's a water-cooled engine. You've got to have water or antifreeze mix in the radiator and airflow through the radiator. Always check the level in the radiator. Be careful when taking the cap off, because you've got to make sure that the hot water is not going to come bursting out there. The expansion tank is in there so that as the water expands, it'll blow into the tank, and as it cools down, it'll suck it back in. So while you've got a level in there, the fluid has to be in this side only. You've also got the dipstick, the high and the low marks there. And you've also got the throttle solenoids, the electric fuel pump, and the fuel filters down there, which we'll show in a minute. A little tip that we've come across in the past: if you do bleed the engine dry of fuel, undo the bleed screw there and go through the start procedure several times, and you'll hear the electric fuel pump ticking away. Hopefully that will purge the system of air. Once you've done that, turn the valve back in and start the engine. Everything should be all right. Do not mess with any of these 4 posts here, because the slightest adjustment could run out the timing of the engine and it will not run. With the panel off the side here, we can see some valves which are to do with the SAFE-Trak and SAFE-Trak system. We've also got the main fuel filter there, and we've also got an inline disposable fuel filter there, so you can see actually how good your quality of your fuel is. This pulley here is the electric clutch for the tracking motors. You've got the 2 motors on the back of it here. Ordinarily, the pulleys are going round, but internally they're not driving the pumps. When you engage the track machine side of the business, these clamp up tight and then it drives the motors there. You need to maintain an amount of pressure on these belts at all times. If they go slack, and they will do initially, undo the main clamp bolts top and bottom, and then use the adjuster there to screw the motors up in the air, and then when you've got the right tension, clamp off the 2 bolts, top and bottom. Top one there, bottom one there. If you just undo those a nip and then use the assembly there to push the motors up, and then clamp them off top and bottom, and then finally just check the tension of the belts again. If you need to take the tension off the drive belts, undo the locking nut there, screw the awl thread in so that the end of the awl thread goes into the cup there and eventually pushes the arm inwards, taking the tension off the belts. One of 2 main rotor bearings. It's a twin spherical roller bearing, so about twice the size you realistically need. Little grease nipple there, 2 or 3 pumps once a week, high temperature grease. That's with average usage of the machine. Grease nipple on the back of the bell housing on the engine here, same again, 2 or 3 pumps once a week. The orange fan here is a patented device. It's in there basically to help suck hot air out of the engine bay, push it in with the wood chips to help the wood chips get blown out of the chipping chamber. Wearing gloves, you can turn over the main rotor assembly here. Like I said, there is no clutch, so you're pulling against compression of the engine, so make sure you keep your fingers out of the way and pull gently towards you. Occasionally it will just go over centre like it has done there, and that shows you the green mech disc blades there. The wood chips come through here as sliced by the blades, and then these impellers here blow the wood chips out of the chamber. You've got a grease nipple in the cup there which protects the nipple itself. That one and this grease nipple here feed the rotor bearing on this end of the shaft, which is tucked into the face of the shaft. When you come to line the machine up, the blades up with the hole there to change the blades, do that there and use something to lock the flywheel in place, so when you're undoing the bolts you're not fighting rotation of the machine as well. From this angle you can see the hole that you can use to get through to get the blades out or turn the blades around. 10mm Allen key, scrape out the hole very carefully with a screwdriver or a pick so you can get good purchase with your Allen key, and you can also see that the grease nipple down to the bearing is fully protected.